Hello SL2, here's the second part of the chain rule. Before we talk about the proof of the chain rule, I want to show you where these formulas are on your calculus or your formula packet. So you all have a formula packet and want to make sure you're seeing why we're using these same formulas so you're ready to use them on any quiz and test and the IB exam. So we're currently in topic 6, calculus, and you can see our derivative of f of x, our definition of the derivative is here, and they show you the different ways that it can be written. Dy over dx equals the f prime of x, and also it shows you the approximate, using h as approximate to help you define. So, and then I know I sometimes call it the h method. So those are all here for you. You don't have to memorize them. Also, here's your power rule. These we're going to be talking about soon. But right now, the one you learn today is here under the chain rule. And then next class and next notes will be about the product and the quotient rule. So just wanted to show you where those are, and so you're familiar with where they are in the formula packet. Okay, so last little bit here, just to kind of prove the chain rule. Here's our definition of the chain rule. And if we consider this f of x as our 2x plus 1 to the third power, we can use the binomial expansion to expand that. And the binomial, so to use the binomial expansion, our first item will be 2x cubed. Then we will have our 3 times 2x squared times 1. Our next term will be 3 times 2x times 1 squared. And our last item will be 1 cubed. Okay, and our next step will just be, I'm going to fix this up while I'm talking you through the next step. We're just going to be multiplying that out, and then we'll take the derivative. So 2x cubed, remember, will be 2 cubed and x cubed. So 2 cubed is 8, and x cubed is x cubed. Here we have our 3 times 1 and our 2x squared. So first we'll do 2x squared, which would be 4x squared, and multiply by our 3. Our next term in our function would be 6x if we simplify that, and our last term is 1. So now we expanded that using the binomial theorem. Now we're going to take the derivative. And taking the derivative using the power rule, again we'd have 24x squared plus 24x plus 6. So this could be written as dy dx or as f prime of x. Here's our derivative. Okay, so let's prove the chain rule. Here we did it the old-fashioned way, multiplying out and then using our power rule to help us derive. The first thing I want to do is look at how to rewrite that in factor form. It'll show you more clearly that our chain rule is going to work the same way. So if we rewrite this in factor form, we can factor out a 6 first, and that will leave us with 4x squared plus 4x plus 1. And then we can factor out our 4x squared plus 4x. Our 6 would stay out here. And then we'd have 2x plus 1 and 2x plus 1. 2x plus 1 times 2x plus 1 would be 2x plus 1 squared. Okay, so proving the chain rule, we're going to use our find the derivative with respect to x using the chain rule. So first, what is our y? Our y would be u to the third power. And then our u is our 2x plus 1. So now we're going to find the derivative with respect to x. First we find the derivative of y with respect to u. So that would be 3u squared. And multiply it by our derivative of u with respect to x, so that would be times 2. Our last step is now to substitute back in for u. So we'd have our 3 times 2 would be 6. And then we plug back in our 2x plus 1 in for u. And you can see that our derivative of respect to x can be found either using the chain rule, and it seems like to me that's much faster, or by expanding and multiplying out, and then find the derivative. So want to keep showing you multiple ways of how to find the derivative, and because every IB problem could be approached differently, and based on your strengths you will pick which one. So that's it for tonight. I hope you guys have a great night, and we'll see you in class.